Hello there, folks. It is Mike with Solutions video number 3, March 17th. This should be the last Solutions video, just as an FYI. And let's get into it. The quizzes are changing quite a bit. So really, there's a first part and a second part. So for the first part, really the first 5 questions, are you starting to understand different forms of data? So data comes in many different formats. Going through these different terms is important. So first one, I'm going to abbreviate them here. Actually, no, I'm not. Categorical. Categorical is versus, there we go. Categorical versus numerical. Categories versus numbers. So first of all, categories and numbers. Categories are like black, brown, white. Could be colors of bears, could be colors of people, could be colors of hair, all those sorts of things. Those are categories. See how they're different blocks and you have to fit into each of those blocks. Or if something was yellow, we'd have to make a new category of yellow. Numerical is like how dark is your hair? So how dark is your hair? That could be on a scale of 1 to 10. Let's say 10 being black and 1 being white. So numerical is a number value that you could theoretically have like 1.5 or like 9.5. Whatever you need here between categories and numbers. But it's categorical versus numerical. So let's look at that first question. I asked, John counted birds out his window every day at lunch. Now that is collecting data. And so John collected categorical or numerical data. Well, he counted birds, so that's numerical data. So for the first one, you would say numerical, and it's because he counted, right? There's numbers in that, not just categories. So that's categorical versus numerical. So on that first one, I'll just leave it like that. Second one. Nominal or ordinal. So nominal versus ordinal. This basically means order. Is there an order to things? Hot, like room temperature, and cold would be ordinal. There's an order. They go in this order. You could also put very hot as a category over here, or very cold to add another one. So ordinal, there is a number, or there is an order to things. Nominal would be like black, brown, and white. There is no order. There is no order to that, which means it's nominal. There is an order to something, let's say very hot, room temperature, cold. That means they're ordinal. So you're looking for order in this pairing. So John counting birds, there is an order to those numbers, 6 birds on one day versus 10 birds on another. There is an order, it is ordinal. So we'll move on to the next one, which is primary or secondary. Primary versus secondary. So primary data versus secondary data this is like at source. At source. You are directly measuring, directly connected to the thing. Secondary is looking indirect, and secondary data is like looking at someone else's observations or experiment. So, what do I mean by that? At source is like you're doing something. I've got this pen. I'm going to look at this pen. I'm touching this pen. I'm taking the color of that pen. That's all primary. Secondary would be me writing out a list of observations that I have about this pen, and then someone inferring data about me based on my observations. Mike is kind of creative. Mike is could only list out 10 things. How many could other things, or how many things could other people list out? Whatever it might be, that's now secondary data. So it's not the data at the source, it's the secondary or the once removed data about whatever we're doing. So if it's about this pen, then it could be observations about aggregates or types of people or groups of people within those studies. So that's secondary. So John counting birds out his window every day at lunch is primary. That is directly John measuring things. And we'd want you to write that down in your answer. We don't want you to just circle things. We actually want you to say, like, primary means because he's directly measuring things. Next up, experimental. Experiment versus observational. So, is it an experiment or is it an observation? This, are you looking at something? This, are you changing something? Are you collecting data based on changes that you made? Is John putting out birdseed to see how many more birds come at lunch or not? This is just looking at people or looking at birds coming through. This experimental would be changing something to see how birds change over time based on different characteristics. So it is just observational data. And finally, microdata versus aggregate data. Microdata and aggregate data this is a specific data set. Specific data set. Microdata is like a set of different data that you have that you might collect off of a survey. Microdata would be a survey. Aggregate data would be the collection of surveys. And then the big part about aggregate data, I'll put it up here, is that there's a change. That we're changing the data based on whatever we're seeing. Maybe there's different categories. Maybe we are lumping different things together. So we're saying the top 25% of people did this. Whereas this is, microdata is a specific person doing a specific thing or a set of circumstances. Here's a country that's doing a specific thing. Aggregate data would be for the world, first world countries or countries with this kind of industry do this and countries without don't. That's aggregate. We're drawing conclusions from larger swaths of data rather than specific set of predetermined numbers. So in that, this is microdata, specifically with John measuring birds. It is a specific situation where he is measuring and observing and collecting microdata, not aggregate data. So those are the first 5 questions. You're going to want to go through and identify those for the data situation that I give you. And then you'll want to write why. So in this case, it's because it's numbers, because those numbers have an order, because they're directly measuring, because they're observing and not experimenting, and because they have a or a section of data that is microdata. It's not an aggregate of multiple kinds of data. So that is the first set of terms that you need to be able to recognize, and slowly I'm going to introduce pros and cons of each of those, because sometimes depending on what you want to measure, there's better ways to measure that. So the second set of questions, we'll go one at a time here. So 6 for x bar, this is the average. And we're at a point now where everyone should be using Google Sheets. Every time you do a question, you want to put it in Google Sheets, and all data should be in there. Should be in a Google Sheet. If it's not, you're going to have a hell of a time with questions 6 through 10. So please make sure that Google Sheets are being used every time when you're putting that data in. Other things to note. We're now giving you 2 different measures. So there's going to be an x value and a y value. So there's going to be a bunch of numbers down here. There's going to be a bunch of numbers down here. And those are going to line up right across. So you should observe that those line up, but each one was going to have an average. This is going to have an average. This is going to have an average. This is going to have a standard deviation. This is going to have a standard deviation. This particular value right here is going to have a z-score. This particular value is going to have a z-score. You can calculate those things. Then the r value is going to be the connection of all of those. How are these actually connected, and what can we say about these 2 different sets of numbers and how they are cross-connected? So first things first, average. You calculate the mean by putting average into your sheet, and then whatever cells you want. So average of those, it's going to spit out a number. In the case of today's data, I'm actually going to leave it just as that, because I don't want to actually show you. No. We can go over, if you have questions in particular, you should be putting equals average, open bracket, whatever the data is. So this would be like the X data. And then you're going to have to do it again, equals average to the Y data. And so all the Y data is selected in here. You're going to click, hold, and select and make sure it's all in those. When you hit enter, it's going to spit out the average. Now that's going to be X bar, and this is going to be Y bar. That's how you calculate the average, or the mean. Question 7 is a standard deviation. Now, I'm going to note that standard deviation of X, that's of the X set of data, is going to be calculated by STDEV and selecting that same data, A1 to A9. Standard deviation, putting that in there. And then the standard deviation of y is going to be STDEV. And then all your y data is going in here. So I'm just giving A1 to A9 as an example of what that might look like. I mean, this is the x, and this is the y, and this is the y. So that's how to calculate standard deviation. We're not going to do the basic math. I want to make sure that you can get these values and that they're recorded. Don't copy over. You will need these values later for question 8 and 9, so let's use them here. So, question 8. Question 8 is z-score. So, each piece of data in this, for example, 15, 18, 19, 20, and 20, each of these has their own z-score. So this is going to have a z-score. This is going to have a different z-score. Now the way that we do this is you have to use the information from or questions 6 and 7. And that is the x-bar and the standard deviation for that set. Because we're doing two different sets, don't get confused with y and x. Make sure that if this is the x, that you're using x bar, and if this is the x, that you're using standard deviation for the x set. So, all that being said, we could actually calculate that, and the way that you calculate it, so the z equals whatever value, so let's call it the number, the value of the number minus minus x bar all over the standard deviation. So what does that mean? So let's say, I guess I could do this really quick. 3, 4, 5, and 5, 7, 17 divided by 5 or 4. Let's call it around 4. So let's say, yeah, let's say the standard deviation is about 4. Okay, I'm going to assume, let's assume x bar is about 4, or nope, is about 19, and the standard deviation is about 1.5. I'm going to assume these aren't necessarily right, so please be cautious. These are just estimates. So if we have those values for that data set of x, now the z-score for 15 is 15, because I'm using this first data, minus x bar, which we have over here, which is 19, all over 1.5. So that would be z equals -4 over 1.5, which if I bust out my calculator, so I break out my calculator and I say 4 divided by 1.5 is 2.6. So the z-score is negative, don't forget that negative 2.6. So negative 2.6 is the z-score for this negative 2.6. We could do the same for 18. How would we switch that? Well, this would turn into an 18. This would now turn into -1. And this would turn into -0.67. So this is -0.67. So in order to calculate the z-scores of each of these, the formula, and I'll write it down one more time. Jody, you good there? Awesome. Thank you so much. formula one more time is for the z-score, we take whatever number we have, whatever number we're looking at, we subtract the average, or x bar, and we divide by the standard deviation of that set of data. It's going to get you a number that's like -2 or 0 or 1. 0 means that the data point is right on the average. It's the expected value. So when I draw this, the average, don't forget, is x bar, which means the z-score here is 0. And one standard deviation over is going to be a z value of 1. And one standard deviation over here is a z value of -1. Two standard deviations over is a z value of 2. And two standard deviations over this way is -2. So you'll see a z-score shows how close it is to the average and how far it is away in standard deviations. So that's z-score. I would recommend putting this formula in. I would recommend putting these values in, but typing them. Type these values into Excel. Don't click on the other one. You need to know a special code for that. It involves a $sign. Don't worry too much about that. Just type those values in and then click and drag, and it'll make it way easier. Question 9. So for question 9, we're looking at R scores. This is the correlation coefficient. This is a function in Google Sheets. So you want to write equals correl.
Just 2 quarters?
And you're looking for correl, and you're going to open that bracket, and then for the first set of text, I'll actually put it down here. So you're going to open that bracket beside correl, and you're going to select all the X text, all the X numbers and values. Don't get titles in there. Don't get extra information. If you happen to put z-scores, make sure you're not like carrying over, that you're selecting all the X columns. And then you put a comma, and then you want to select the Y text, and you want to close that bracket. Now, this is going to give you an R value. So R is going to be between 1 and -1. That's what this fancy thing is. It basically says -1, R must be between -1 and +1. So, what does that actually mean? Let's say your R equals 0.99. That means when your X value goes up, your Y value goes up as well. And it goes up almost at the same rate, proportionally, that is. It doesn't go up the same amount because the numbers could be different, but it goes up proportionally by the same amount. An R value of exactly 1 means that these are perfectly connected. When one goes up, the other one goes up 100% of the time. When our R value is -0.99, when X goes up, Y actually goes down. But it goes down in proportional ways. And so if R equaled -1, then for every step X goes up, Y goes down in the exact same amount proportionally. So when an R equals either -1 or +1, or a really high number close to 1, it means that there is a connection. That these two things are connected. The correlation coefficient, these are correlated, these are connected in some way. Now, what happens if the R equals 0? Well, that means that if x goes up, y could go up, then down, then up, then stay down forever. You know, it's random. There's no connection. As x goes up, y changes at a really weird rate that is not connected. I gave the example in class of like votes. So like who gets voted for, and like ice cream. Like chocolate ice cream isn't connected to what people vote. So if you eat chocolate, it's not like you're likely to vote one party or the other. Things that might be connected are like who you vote for and like how much money you make, because richer people tend to vote more conservatively. So on that, it might actually be that those things are connected. The more money you make, the more votes that are cast for that party. And then in that case, R would be, let's say, closer to 1. So this function, where you're selecting all the x text, comma, the y text, closing the bracket, that's going to show you what's going on for R, the correlation coefficient. And question 10 is about all this stuff. So how do you connect these two things, and what does that mean? What does an R of 0 or an R of 1 or an R of -1 mean? R of 0 means there's no connection. R of 1 means that when one goes up, the other goes up. And when R of -1 means when one goes up, the other goes down. So that's the new 10-question quiz. If you have questions, please let me know. But don't forget this Corel formula to put into Excel or the spreadsheet. Thanks very much.